This one will be pretty easy. We're going to talk about congruence, which we've already talked about. You know, about congruent line segments, congruent angles. Here we have congruent objects, in this case polygons. We're just going to worry about triangles right now. What does it mean for a triangle to be congruent to another triangle? It means that all the angles and all the sides are congruent. For instance, if I probably ought to label these. There we go. Now we've got some labels and we can talk about them. These two triangles are congruent. Why? Well, I drew them that way. Actually, copied them. To be congruent means that A and A prime are congruent, B and B prime are congruent, C and C prime are congruent. But not only that, this angle and this angle, these two angles, and these angle pairs are also congruent. Instead of labeling them, I just drew in the hash marks to indicate that they are congruent. Could have done the same thing over here. Suppose I did this instead of labeling them with this one. Like that. And we can add the little hash marks to show that these sides are congruent here. What about these triangles? What the heck are these things for? Well, don't want you to get the impression that two triangles have to be oriented the same way in order to be congruent. They don't. This one is basically this triangle flipped over on its side. Rotated 90 degrees, in other words. It brings this side over here, but they still have congruent sides and congruent angles. And over here, it's just how you arrive at this upside down version of this. There's two ways to do it. We can rotate this all the way around, which brings this corner all the way over here, which is the way I drew it here. Or we could flip it. Just drop this thing straight down where there is no rotation. Look at it either way. You'd still end up with this, but the corners might be in a different spot. In other words, this corner would still be where it is. This one would just drop down. And A would be over here and not over here, depending on whether you rotate. Let's just draw it in. If you take this side and rotate it 180 degrees, then you end up with this, or you could flip it. How you want to look at it is up to you. The important thing to remember is that the orientation in space and the position, those are irrelevant to whether a triangle or any polygon is congruent or not. Just has to have congruent sides and congruent angles. One important result we're going to use when we work the problems. Real simple. It's almost obvious. You won't have any trouble with it. It's called the third angle theorem, or third angles. Not sure why they pluralize it. That's their business. And what it says is, we've got two separate triangles. We don't know whether they're congruent or not. And when we get done, we still won't know if they're congruent. But we will know that at least it is, the angles are all congruent. How are we going to know that? Because we've drawn it in such a way as to show that two of the angles are congruent. This angle is congruent to this one. This angle is congruent to this one. What does that say about these two angles? Well, it's real easy to see that they're going to have to be congruent also. Why is that? Well, if we call this one, let's say that's A, and that's B, and that's C. These two are congruent, so let's call them A prime and B prime. And we don't know what this is yet, so let's just not call it anything. I used the prime to indicate that there's a definite relationship between these two. In fact, in this case, we know that they're congruent. So what does that mean? Well, a plus b. Here I went ahead and wrote it out and rewrote this line correctly. I have a very bad habit of just throwing in the variables and not adding the part in front that indicates whether it's an angle or the measure of the angle. In more advanced classes you start throwing out some of this stuff and just going back and forth, constantly referring to the angle and the measure of the angle with the same variable. The context tells you what you really mean. That's how I acquired that bad habit. Now that it's written correctly, what can I do with this? Well, it's pretty obvious, I think. You've seen me do this plenty of times before. Suppose I just set this equation equal to this equation here. What's going to happen? And by now, I'm sure you remember, if we have two things equal to a third, we can set them equal. That's just our, well, again, it's the transitive property or the substitution property, depending on how you want to look at it. Since this equals 180, we could say we're substituting this in for 180. Or we could say that since both of these are equal to the same thing over here, we set them equal using the transitive property. Either way, what happens? Well, if we solve this, we can start just throwing stuff out, right? We got the measure of angle A over here, and so subtract that from both sides, subtract that from both sides, and what do we get? The measure of angle C is equal to the measure of this unknown angle, which means they're congruent. And you probably knew that before I even did any of this, because I mean, they add up to 180. You've got two here that are congruent. We got two here that are congruent. What's left over must be the same for each one. That would be the simple and a grade school way of putting it. But who cares? It's an easy way to remember it. It's an easy way to see the truth of it too. Memorizing theorems is a pain, but recognizing the truth of this, spotting it quickly and easily, and then using it in your proofs or solving problems, that's pretty easy. There's one more pretty simple thing to know before we work any problems in this section. And these are just the corresponding properties of equality and congruence in general for triangles. Or we did this with congruent angles and congruent lines. This is a property of congruence, which we're already familiar with, the reflexive property. Triangles are congruent to themselves. That makes sense. Symmetric property. It doesn't just go one way. If this triangle is congruent to this one, then it goes both ways. This triangle is also congruent to this one. In the transitive property, we've got two triangles, both congruent to a third, then they are congruent to each other. Probably exactly what you would have guessed. And if you don't like these, then figure out how you would work problems if this wasn't true. Things would be kind of messed up if this didn't work out. So, what did we do wrong here? The corresponding angles of these triangles are congruent. So the triangles must be congruent. That's not true. They could be, but they don't have to be. Why? Remember, congruence has more than just the angles are equal. Okay, still got it up here somewhere. These sides also have to be congruent. It's not enough that the angles be congruent. That's a good start, but that's not the end of it. The sides also have to be congruent. And that's the part that doesn't seem to hold right here. These sides definitely don't look congruent to me. Here they'd like us to find the values of x and y. Like the first thing we can spot is that this over here must also be a right angle. How do we know that? Well, there's two ways. Remember, we have that theorem that says if two lines cross, so we could extend this, they're perpendicular, then there are four right angles created. We could say that. There'd be two more down here. Or we could say that this is a straight angle, therefore these two form a linear pair. They add up to 180. But this one, we know, is 90 degrees. This one must be 90 degrees also. There's at least two different ways we can know that this is 90. There might even be a third one. What else do we know? Well, they drew a little line in here to indicate that this angle and this angle are congruent. There's no other reason. There's no way that you would know ahead of time that these two were congruent. We don't have any theorem involving the way this thing cuts, or there's just nothing we have that would tell us these two have to be congruent. They're just letting us know with this little line in here that they are. So right off the bat, we got one equation we can write, which is 12x plus 4y. Wow, that's a 4, okay. Equals 40 degrees. And what happens if we solve that one for y? Well, let's see, we'd have 4y equals 40 minus 12x. Or y equals 10 minus 3x. I think that's right. Okay, so we have an expression now for y. Why would we want that? Well, because we have to solve for both x and y. We've got two variables. It's better if we can get one variable in terms of the other. That way when we substitute in here, we only have one variable to play with. Well, if these are congruent, that means this is 40 degrees here. This is a 90 degree angle. 90 and 40 is 130, and that means this must be 50 degrees right here. That adds up to 90, and 90 is 180. So we can set this one equal to 50. But two variables, one unknown. No good. Let's substitute our expression for y in here and get that 17x minus 10 minus 3x equals 50. So that becomes minus 10. That becomes plus 3x. So when we lay this out, it's going to be fairly simple. As I said, we've got the expression for y. We put it in here. And now all we have to do is just expand it. We got minus 10 plus 3x here equals 50. And do a little rearranging and get to 20x. Remember, add 10 to each side. Add these two up and get to 20x equals 60, or x equals 3. Well, that puts us halfway there. But we still don't know what y is. But we have this expression here. For y, we just plug our 3 into here. So when x equals 3, that means y equals 1. So the values are x equals 3 and y equals 1. And we can double check. We have here 3 times 17, well, that's 51, minus y, which is 1, that's 50, and this is supposed to be 50 degrees. So our quick little check shows that 3 for x and 1 for y are in fact correct values. Now here's one that's kind of cool. According to this, these two triangles are congruent, and these two triangles are congruent. What does the transitive property of congruence tell us? These two, we can jump right past this one and say that these two on the end are congruent. So what? Well, one of the things you should notice is that when we label it, we try to put the congruent parts in the same order. In other words, angle A is congruent to E, and angle E is congruent to angle G. I could have labeled this like E, F, D, but that'd kind of mess things up because of the way I wrote it. If I wrote it that way, then I would have to write this to maintain the convention D, E, F because of the... I'm not explaining this very well, am I? Not at all. We tend to put these in the same order as their congruents. So that angle A is congruent to angle E. Angle B is congruent to angle F. In other words, the first one you write in your labeling process is congruent to the first one you write over here. The second one is congruent to the second, and like that. It's an extremely simple concept that I'm having a real hard time explaining. But let's just work this problem. We got angle A is 90 degrees. Well, I certainly drew this wrong because that doesn't look anything like 90 degrees. We'll just live with it. Angle F is 20 degrees. I admit that doesn't look much like 20 degrees either. What is angle H? Well, this isn't really all that tricky. Remember, these are just duplications of the same triangle. This angle is congruent to this angle. This angle is congruent to this triangle. So, I can put those two numbers in here also. And remember the previous section? They have to add up to 180. So we got 90 and 20 is 110. So it looks like this would be 70 degrees. Is that answer up there? Oh, there it is. Good. That's all you had to do. And in fact, when all we had was this angle and this angle, you probably could have immediately written this down as 70 without going through all this. But this makes it a little more obvious way to see it, I guess. Here's one of those fill-in-the-blank proofs. Not too bad. They list the given here, but it's easier to just look at it. All they're doing is rewriting what the diagram says. This side is congruent to this side. So, we can see from the diagram we have 3 congruent sides, if that matters. It doesn't really mean much in this proof. We also have that this angle is congruent to this angle. That's given. So we have a triangle, 2 triangles with 1 congruent angle that we know of. If we had a second congruent angle in each of these, then we would know that the third angle was congruent as well. That's from our third angles theorem. Well, what about this part here? BCA, what's that? BCA. And DCE, that's this one here. What does that make these 2 angles? A vertical angle pair. So that's true because they're vertical angles. Vertical angles. Now, what else is true? Well, since I guess I could draw, I have room to put 4 hashes. Oh, I see, angles. Okay, we'll do it that way. 2 hashes. These are angle hashes, not side hashes. So I get them confused. So these 2 angles are equal. These 2 angles are equal. From our third angle theorem, we can say that ABC, and I keep saying equal. You know, I mean congruent. The measures are equal. The angles are congruent. By the end of this course, I will have corrected myself so many times, you will know this better than I will. Or do. This angle is congruent to this angle. So we have two of the three angles which are congruent, and from our third angle theorem, we know that ABC and CDE are congruent. So we have that angle ABC is congruent to EDC. Why? Well, third angle's theorem. And this is true from the definition of congruent triangles. From the definition of congruent triangles. So it turns out we did know that these, tripping over my tongue again, we did need to know that these sides were congruent, because in the end we were trying to prove that these two triangles were congruent. We've shown that we already know, it's given that all the sides are congruent and one of the angles is congruent. We were able to show that these two angles also are congruent, and that means that the third angles left over, those are congruent also. So we have that all the angles are congruent and all the sides are congruent. And that's the definition of a congruent triangle. And I guess I should have said congruent triangles. It's hard for a triangle to be congruent all by itself, except in the case where it is congruent to itself. And that's kind of silly. Now this one's not bad. We can figure out all the angles in this shape here. Kind of looks like a kite, doesn't it? By only computing two of the angles in this triangle here. For instance, suppose we got these two. This one, we'll call this, suppose I put it up here, A and B. I know the measure of these two. Well, if I flip this, in order to create this here, that's really what's going on. We just flip this one and then put them together. That's what this tile is. So this is already angle A. This one here, well, we just put the two of them together. So don't you think maybe this is 2 times the measure of angle B? And we just flip this, so this is still just A. This is just corresponds to this one here. And over here, whatever this angle turned out to be, and this is 180 down here. Let me write it up here. 180 minus measure of angle A plus the measure of angle B. That's what this angle here is. Let's just call that C, okay? But we do know what it is from our from our triangle sum theorem, which tells us that it all has to add up to 180. So if you know 2 of them, you immediately know what the third one is. So we'll call that C, and we know it because of this relationship here. And this would, of course, be 2 times the measure of angle C for the same reason as over here. Pretty simple. I don't think you'd have any trouble working that out. You see how it goes. Here's one that's may not be that obvious right off the bat here. But they're not lying. It's a multi-step problem. That's exactly how you just have to approach this. How do you know that BE is congruent to DE? Well, we're given that this quadrilateral is congruent to this quadrilateral. I think we went over quadrilaterals earlier. It's just a general term for a four-sided polygon. That's all. It's no big deal. Just like triangle is the general term for a three-sided polygon. Quadrilateral is the four-sided polygon. I believe we already went over that. How do we know that these two sides are congruent? Well, because the quadrilateral is congruent and the two quadrilaterals are congruent. From the definition of congruence, the sides are all congruent and the angles are all congruent. So we could put a couple of hash marks there to show that they're equal. Congruent, sorry. And that ABE is congruent to CDE. Well, gee whiz, same thing. We're already given that the quadrilaterals are congruent, so the corresponding angles are congruent. So that's just from the definition of congruence. Explain how you know that angle GBE, let's see, where's that one? This one here. And GDE. How do we know that they're congruent? Well, this here, again, we know that this must be also a 90 degrees. We could use either one, like I said before, either one of a couple of theorems. Or just spot that this is a straight angle. These two form a linear pair. The little red right angle thrown in there tells you that this is 90 degrees. So 90 and 90 is 180, so this one must also be 90 degrees. I know I keep saying that over and over and over and over, but repetition's a big part of learning. So this angle is congruent to this angle. Why? Because they're both 90 degrees. What about these two angles? Well, this is congruent to this one, which means this is a perpendicular bisector. But we don't know enough about those sort of things yet to use that as a reason. So we have to find some angles here that we know are the same. What else can we do? How about this? These two quadrilaterals are congruent. That means this angle here, ABE, must equal CDE. In fact, we used that right here. We showed it. Well then, these two form a linear pair. So this angle here is 180 minus this, and this one is 180 minus this, but these two are the same. In other words, if I call this angle x, then this angle is also x. That means this is 180 minus x, and this is 180 minus x. So these two angles are congruent. Now, from our third angle of congruence theorem, we know that this angle must be congruent to this angle. So these two are congruent because they're 90 degrees. These two are congruent because they are both supplementary to the same angle, or an angle with the same measure. And our third angle theorem tells us that the third one here. So actually all three of these, that's not actually what they asked for. All they wanted us to do was show that this one and this one were congruent, but in the process it's pretty easy to show that all three are congruent. And in fact, it's pretty easy to show that these two triangles are congruent. Why? Well, we just showed that this angle is congruent to this angle. We already know these two are congruent, and our third angle theorem tells us that this angle must be congruent to this one. So we have all congruent angles. That's not quite enough. We have to also have congruent sides. The diagram tells us this side is congruent to this side. the fact that the quadrilaterals are congruent tells us this side, because this segment here is doing double duty, right? It's part of the triangle up here, it's part of the quadrilateral down here. Same thing here. Because they're part of these congruent triangles, we know that these two are congruent. That just leaves this one. Well, this one is congruent to itself. So, all the sides are congruent, all the angles are congruent. So, these two triangles, they are congruent. And that was actually, well, let's see here. So, kind of answered these two all together at one time. And this one, well, I just answered that one also. I hope you understood what was going on here. It's a little bit complicated. Maybe I should have made this drawing bigger. But you get the idea here. It mostly hinges on the fact that these two quadrilaterals are congruent. Based on that, we can say a lot of things that help us determine the congruence of the angles and these two sides. So it looks tough, but you say just go through it one at a time, and it all starts to drop out. And in the end, it's really not that tough. Well, that's about it. Remember, the important parts this time were congruence and the third-angles theorem, and of course all those properties that you're already familiar with: reflexive, symmetric, and transitive.